from University of Kona. And then he got his a second master and a PhD in cognitive and behavioral neuroscience from University Pierre and Marie Curie in Paris. He's still in Paris. And now Stefano is a research director, that is professor, maybe in French in some way in your coordination, and the head of the human reinforcement learning team, which is part of the cognitive and computational neuroscience lab at the prestigious École Normale Supérieure in Paris, also in CERM, that is French National Institute for Health and Medical Research. His research focuses on understanding how human learns to make decisions at the behavioral, computational, and neural levels. Much of his research is more similar to many other people in this group and focus on decision from experience. He has published in top journals, including, just for example, two papers last year in Nature and Human Behavior. Hopefully he will tell us about this research. Thanks, Stefano, for participating.
Yeah, thank you, Ido, for the invitation, the introduction, and it's a pleasure to be speaking to this community. Many of you already know in person, but most of you, I know your work, and it's really, humbling. So I will present essentially one study, which was entitled "Feedback Anticipation-Induced Dispositional Change," but we may change this title with attitudinal, because we recently got reviews that maybe disposition is not the good term, but actually not all my co-authors are maybe completely full on board on this term. So maybe you can also tell me at the end what we should use, okay? But I think at the end, based on the results, everything is going to be a bit clear. I assume you can hear me fine. And as I said before everybody arrived, do not hesitate to ask me questions during the talk, clarification question or whatever, so that we are sure that everybody's on board. All right, so actually, yeah, one of the reasons, since this is not really my community, I didn't put an affiliation on the first slide, was because I wanted to tell you a bit more that indeed I work in the École Normale Supérieure, which is an institution in France. I'm part of a laboratory that focuses on the neural and computational basis of cognition, and there are a few laboratories, including mine, that are more focused on value-based decision making. So my team is called the Human Reinforcement Learning Team, because most of the traditional topic in my lab is really reinforcement learning, as it is studied, for example, with bandit tasks, actually mainly bandit tasks, and but today I will not talk about this line of research, because I thought it was more relevant to present you the last opus on a new line of research in my team that is more linked, I think most of you do, which is the experience description gap. And something that I started doing very recently when I started reading your papers, essentially. I think these are the couple of papers that Ido was referring to, and I will not present them, but I wanted to a little bit to advertise, because since it is not my community, maybe some of you may have missed, and they are not exactly canonical maybe in the field, but yeah, that's what we have done so far. But today I will present you a new and published studies. It's actually currently under revision in a journal, but still will be room to integrate more things, and we'll see. Okay, the introduction is going to appear a bit boring for a lot of you, but again, since maybe sometimes, as Ori said, the audience can be diverse, hopefully some introduction can be useful, right? So I'm going to talk about decision making under risk. These kind of decision problems are what some people call the Drosophila, their basic model to investigate this process. It's choice between lotteries. This is not how we have studied originally this, but many people use this kind of decision problem, which there is a choice between a safe and a risky option. Okay, a sure option, etc. Now, there is sort of optimistic, naive view, for example, in neuroeconomics, that see value-based decision making, we can say, as it should, as an integrated framework in which you have evaluation, learning, action selection, all in a unified process. But then we know very well that when we look at how this process is actually studied in humans, there is a sort of dichotomy between these two intellectual traditions. So the one that I just show you with the lotteries, this on the left is another representation of the lotteries in a visual manner with pie charts, which is more in behavioral economics and judgment of decision making. And then there is another tradition, which is experience-based, in which the value is learned by trial and error. The second one traditionally also comes from the animal learning literature. And one key difference is that in the former, there is no role or importance of feedback, while in the second one, feedbacks provide essentially the fuel for decision making. Okay, and as you know well, there is, I mean, this distinction is not only academic, it's not only theoretical, it's not just methodological point, but this is also very important because we know that, for example, if we look at preferences elicited in a description-based manner, we found, for example, prospects like distortion, such as probability weighting, loss aversion, etc. But when we look at the same thing from an experience point of view, we find different results, different probability weighting. In my lab, we found often a form of loss neglect, etc., etc. Okay. But then I would start my talk by arguing that these two extreme paradigms, so pure description and pure experience, are probably not the more ecologically relevant one in real life, right? So because I mean, first of all, we are not rats in a Skinner box. We are almost never in a pure reinforcement learning situation in which we have no clue, no prior information concerning the value of option. There is no shortage of advice, advertisement, etc., that give us a sort of initial value by description of something. But then we are never really in a pure description situation, right? Because we experience in many cases the feedback of our choices, virtually in all cases, and in many cases, except maybe get married or buying a house, we can actually make the choice several times, the same kind of decision, right? So probably what it's more important and more ecological paradigm is what we can call the description plus feedback, in which you have an initial information about the prospects, and then you receive a feedback, and then you can use the feedback to do something, for example. Okay, and this paradigm is not new. I'm saying just that it is comparably less explored. Okay, but okay, so this is bring us actually to the first research question. Essentially, the first research question that we had, and also because I was new in the field, was but what is the effect and what are the possible mechanisms that mediate the effect of feedback on decision making under risk? And in particular, I was focused on two metrics. So the first one is risk preferences, asking whether feedback make people more or less risk averse, or it depends. And the other one, which is more linked to the reinforcement learning literature, is optimality, understood here as expected value maximization, not expected utility, expected value maximization. So the objectively best option, right? As I said, there is nothing new here. And our paper started with a probably not exhaustive review of the literature, of survey of the literature, in which we try to identify several papers that use this design, description plus experience. And we try to see what were the emerging average trends in the literature concerning the thing in respect of these two metrics. And essentially, when we look to the effect of feedback on risk, we generally found an increase, but not consensus. And when we looked at the effect of maximization, many cases it was not reported. And again, even less of a consent. I mean, there are less cases in this case. And we also identified, I mean, we approached this literature, and there was many, including many of yours, but very interesting study. But nonetheless, we identified some things that maybe we could bring to the debate. Okay, so for example, asking the question of risk of optimality, we realized that in many studies, risk preferences were confounded with optimality, because it is true that in many cases, in many experiments, the option with the highest expected value is the risky option. And in many studies, you didn't have a a control condition in which it was the opposite. Similarly, they relied rarely on factorial design as we psychologists like it. There were other confounds, such as, for example, order effects, so feedback and non-feedback trial, they were not in an orthogonalized manner. The feedback and non-feedback trials oftentimes confounded also the number of trials. So you have one-shot description without feedback, and then several, etc. So we wanted to clarify this.
I have a question about. I can have a question about literature. There are many papers on learning how risky choices impact future risky choices. So there must be hundreds of papers of that. Are they incorporated in your literature search?
I don't think so. I think the inclusion criterion for us, I mean, we may have missed a paper, and then at the end you will see we are not making really a meta-analytical point, right? Was having a feedback on top of a lottery contrast with the same lottery without feedback. So I'm not sure that your category belongs to this category, unless understood, if I understood correctly.
The difference between feedback giving or not, that's not indeed very central in the literature I have in mind. So now I understand better what you were talking about. Okay.
Okay, thank you. So exactly. So really, is this role of feedback? Okay, thank you for allowing this clarification. Okay, and then the second question, maybe the second research question is that when we established what is the general effect of feedback in this risk, what is the psychological mechanism? And as I mean, in what I would define as the dominant hypothesis is that this effect of feedback on preferences should belong to a sort of a meta category of model of process that are either learning, you can call it learning, update, sampling from memory, which essentially you get information by feedback, and this information by feedback change your prior representation, be them in a reinforcement learning manner, the Q values or the expected values or the probability, etc. Okay, so this according to this hypothesis, that to be completely honest, was also my hypothesis when I approached the question. So I was presumptuous. I just wanted to come up with a better learning model for this, right? So if you are in this kind of hypothesis, so you will have some sort of, let's say, toy behavioral signatures, right? So first of all, we have the fact that the difference between the feedback and no feedback condition, forget about the directionality, should be something that emerge with learning. And second, but this is into bracket because it is more complicated, but in many cases, some learning tools should go in the direction of debiasing choice and maybe increase optimality as defined as expected value maximization. And then an alternative hypothesis that in our case was generated after the first two experiments of looking at the data, what we may call now an attitudinal change, in which instead of being a learning or a belief update process, it's a change of attitude induced by the anticipated states of receiving a feedback. And in that case, we will predict different dynamics, for example. So first of all, the effect should be present since the beginning, should not be incremental. And maybe there are less chances that this should be associated with an increase on optimality, okay? So this is our background, and then this is the methodological, the task that we used, right? So we used decision problems defined by a magnitude of outcome with a given probability, etc. They were always structured more or less in a sure versus a risky option. We implemented the 10 repetition. We used the 3 levels of probabilities and 2 of magnitudes. And we manipulated also 2 important features that I'm going to describe here. The little table here is maybe a little of a pain to look at it, but essentially show you the decision problem. So you have 3 probabilities, 2 magnitudes for the risky prospect, and then these are compared to a fixed outcome of 100%, which exists in 2 versions, in a risky better and in a sure better version. This is the typical trial. So a block start, we ask the subject just to press a button to start the block. Then the subject is presented with the two prospects, no fancy camembert or pie charts, etc. The probability and points just described in a numerical manner. We also, by the way, included a lot of dominated choice, block choice, to exclude the subjects that behave non-rationally in dominated choice. To be sure that you understand that is the basic of what 100% mean, etc. And then if we are in a feedback situation, the subject receive a feedback. And then if we are in a no feedback situation, the subject is not informed about the decision. And then we repeat this trial 10 times, and then we have the end of the block, and then we start again. So the
feedback is limited to the selected choice.
In the half of the experiment, yes, Ido, but I will present results from the complete feedback scenario. The first result I'm going to show you is the partial feedback scenario. So in this case, they will receive feedback only about the chosen option, indeed.
And how do you translate points to money?
What is the translation of the points to money? I don't remember exactly. I can tell you that by standard, so we did the two class of experiments. We did the laboratory-based experiments at the end. Actually, I will present some of the results, and online experiments. And if I remember correctly, online experiments were paid double the hourly fee of Prolific. So still, I think below, in average, below £10, but much more than the average experiment.
No, but each point was worth a certain amount of cents or something like that, or
yes, something like that. I don't remember the number exactly.
So, but you pay for the sum of the payoff or for randomly selected trial, or
we tested also both versions, and in the online experiment, it was one random trial that it was picked.
Okay.
Yeah.
Stefano, I have a question. Maybe I missed something.
No, yeah, please.
The main difference between the regular clicking part and that we usually use is the self-paced, or the because
I mean that's for I don't know if it is a main difference. I'm just for completeness mentioning that it's self-paced, but just because we didn't want to impose a delay, right? At this stage, I'm not claiming that there is any structural radical difference with many paradigms in the past, right? So, except we generated the decision problem with not necessarily decision problems that were used in the past, etc.
Can I ask a question?
Sure.
So for this one here, people see the same two lotteries for 10 times. So they see that, they click, they receive feedback, and they choose again, right?
Yes.
And then that feedback counts towards their sum or something, or?
So there were two versions of the task. I think in the most of the results I'm going to present is any trial can count in the results. So there is not portfolio building. It's one random. I think it's the most standard version in behavioral economics. I'm not an expert, but I think that to avoid accumulation of money, whatever, to avoid changing the value at the beginning and the end of the experiment, we took one random trial.
Okay. And only for 10 samples. So sampling wasn't free for participants.
No. So first of all, I think it's important, Manos, you understand that this is not sampling. I mean, it's not you sample and then you choose. Each and every one is a choice, right? Okay. I'm saying this just to deconfound with what is called traditionally, I understand, the sampling paradigm. So this is not a sampling paradigm. These are each and every one is a choice. The difference between the condition is in one case, you got to know immediately what is the results of the choice. In the other one, you don't.
Okay.
Thank you very much for very important that we clarify these aspects. Thank you. Yeah, so just to say briefly that one factor that we manipulated orthogonally to the other factor was this risky better versus risky non-better option. So here, for example, in this case on the left, you can see that the risky option with accepted value 20 is against an option with accepted value of 19. So risk is better, and conversely is the other one. Okay, not rocket science. And we can also discuss the fact that the difference is not so big, but at least we have an objectively good option that is orthogonal compared to the risky option. Okay, let's see these results. Okay, so first of all, the first important variable is risk propensity, and I'm going to show you the effect of feedback on risk propensity. In general, except when it is interesting, I'm going to show you average results, but I will unpack progressively. Okay, so here on the left, you have the no feedback condition, and on the right, you have the feedback condition. Okay, here essentially the error bar is the error of the mean, the box is the confidence interval, and you have each individual point. And when an individual goes in the direction of the main effect, it is in orange. That's the visual representation that we have. Okay, so we can see a small, I mean, 5% something like that, but no, even more than that actually. But nonetheless, a very significant main effect, meaning that all things being the same, the number of choice, the decision problem, etc., people is more risk prone, is still at least risk averse in average, but take more risk in the feedback condition. Okay. We then look at the other variable, is the opt maximization, and concerning maximization, we found in this first experiment, at least, but it's gonna be the same anyway. No effect. So you can see that the level of maximization is above chance, but it's not different across the two conditions. You can just unpack this interaction. For example, if you look at the variable risky choice rate, you can see that when you are in the sure better condition, risk rate is in average low compared to the risky better. Can you see my mouse, by the way?
Yes.
Yes.
Great, thank you. But then you can see that in both conditions, the presence of feedback creates an augmentation which is of comparable size. And now, if you look essentially at the same thing, but focusing on the optimal choice rate, you basically observe that feedback is detrimental in the sure better condition because it increases risk taking. It is beneficial in the other one. Okay.
Stefano, can I interrupt for a second?
Yes.
Can you please clarify again? Maybe I missed it. How many choice tasks each person made, and what's the?
Okay, so essentially you have 1, 2, 3, 4, 5, 6, 5, 2, 2 again. I mean, the type of decision problem essentially is 12, and each decision problem was repeated the same amount of time with and without feedback. And this time was 10 trials per block.
So sorry, can you go back to that slide again?
This one?
Yeah. So what are these numbers in the what are these entries? The 28, 19. What are these?
Yeah. Sure. So for example, can you see my mouse?
Yeah.
Okay. Right. So these give you a full description of the decision problem. Okay. So for example, this decision problem was 5 with 100% against 60, 10%.
Oh, okay. So these are the safe options. Okay.
This is 28 against 60, 50%, etc.
Okay,
etc.
Okay, I see. Thank you.
Yeah, sure. Not the more intuitive graph to show in a presentation, but I hope this clarified it.
Okay, thanks.
Okay, right. Okay, now let's come on the dynamics equation. Okay, if it is so there is an effect, first of all, not an effect of optimality. Okay, but now we can ask, okay, how this effect is generated by learning or whatever. Okay, so now you have across all possible trials, all 10 trials within a block. Okay, the difference between the feedback always in green and the no feedback condition always in blue. Okay, as you can see here, they start at the first same preferences, and then the curves separate, and then they remain, the difference remain there, essentially, with a general decrease in risk taking across trials. Okay. Now, the question is that this is a little bit frustrating to answer our hypothesis, because you may wonder whether this is actually the reflection of one-shot learning or actually a change of attitude. Why it is the case? Because after the first trial, given that in this task, the subject was not informed whether it was a feedback or a no feedback block, after the first trial, two things happen, okay? First, the subject receives a feedback, and therefore she or he can learn from this feedback. So that would be a learning hypothesis, a particular class of the learning hypothesis, a one-shot learning hypothesis. But also, after the first feedback, the subject discovers that the subject is in a feedback trial. So it is also the sign that the subject, she or he, has to modify the strategy because the experience is going to be different. Okay? So to tease apart these two hypotheses, what we did is that we modified experiment 1 so that instead of having neutral block-wise instruction, we had instruction in which we manipulated the instruction. So we had block instruction in which we explicited the information. So we replaced the neutral message with a specific message that told you in this block, the obtained outcome will be revealed, or in this block, they will not be revealed, okay? So let's see in this second experiment how the results go. So first of all, we completely replicate the effect of feedback as a form of, the effect of feedback increased risk taking. The feedback has no impact of optimality. So these are the replication of the first result, which is good. And then let's see what happens at the curve. So in the first experiment, you can see that there was no difference in the first trial, but a difference in the first trial. And this is what happens in the second experiment. Now that the subject is aware since the beginning that feedback is going to be provided, the preference over risk are already set up at a different level. So what we may call a change of attitude. Anyway, there is a change that is not driven by learning, but is driven by the expectation that the task will deliver a different experience to the subject. Then you can wonder, what are the psychological mechanisms of this process, okay? And the first thing, we thought things were simple. We started reasoning like that, okay? There is, of course, an informational asymmetry between the risk and the safe option. Sorry, not the sage option, the safe option. And meaning that if you don't have to pick the sure option to know what is going to be the result of the sure option, because it's 100%. On the other side, only in the feedback condition, only choosing the risky option, you will be able to resolve the uncertainty about the state of the world. And we know for another literature that there is a positive value associated to this uncertainty resolution, okay? So we saw that this was a plausible interpretation of this effect, but it also, of course, reasoned that this would work under partial feedback condition, right? And this we came on the transition for partial to complete. Because if we are in partial feedback condition, we will not only know the feedback of the chosen option, but if we are complete, we don't have to pay the price of picking the risky option in order to know what is the result of the risky option. So we were very optimistic. We thought things were simple, and we know, okay, let's move to the complete feedback scenario, which now you are informed also on the complete feedback. And what is going to happen is that it's going to reduce this effect, okay? So now we are doubling essentially the design. We have the same manipulation, so with or without block instruction. And we have two kinds of feedback, partial and complete. And we went looking at the results, and we started being surprised in a way, because now when you look at the risky choice rate in experiment 3 and experiment 4, it actually, no, maybe the size of the effect may be a little bit smaller, depends. But you can see that also in the complete feedback scenario, we have an increase in risk propensity, okay? So it's actually replicate the first experiment, despite the fact that the informational regime is quite different. We look at the effect of optimality, and we find no beneficial effect. Actually, even more paradoxically to some extent, only in the complete feedback scenario, we found a detrimental effect of feedback. We come back on this later. But anyway, clearly not an improvement. And now let's see what's going on in the temporal unfolding of the results. Essentially the same thing. So in the absence of instruction, the effect emerged after the first couple of trials. With instruction, the effect is actually significant, however small, but more or less of the same size since the first one. So what's going on? we basically replicate all the key results and the directionality of the effect of feedback in terms of risk-taking, no effect on optimality, not sign of a gradual learning effect. But we know that epistemic curiosity cannot work. So we started thinking, and I think I will provide support to this, that there are probably two different interpretations. So first one is that indeed, maybe it is a plausible thing that epistemic curiosity play a role under partial feedback information. And then reasoned that some different mechanisms in the complete feedback was creating this effect. And we speculated about an effect of anticipated regret. Why? So regret, it's, I mean, I'm talking in a dangerous water, but you can understand as being proportional the difference between the obtained and the foregone outcome. I mean, it's an outcome comparison term, either hypothetical or realized, okay? And since we are in a partial feedback, in a complete feedback situation, we are going showing in the face of the subject this comparison, right? So we reasoned that the anticipation of immediate regret should be stronger in the complete feedback than a partial feedback. And then we also speculated about different properties of this regret effect. So essentially, this regret effect, if we define it as between counting the times in which your chosen outcome is smaller than the foregone outcome, should be a monotonic function of the probability of the outcome, because only in the case in which the risky option is associated with a high probability outcome, the risky option is the regret minimized option. So to test this, we did something, is that remember that we luckily in our design, we used the 3 different probability levels, okay? And we plotted the effect of feedback across the different probability levels, okay? So as you can see here, in the partial feedback experiment, the effect of feedback is completely the same across the 3 probability levels. But intriguingly, and consistent with the regret hypothesis, in the complete feedback scenario, the effect of feedback is a function of the probability level. Now, let me plot the difference, the contrast, feedback, no feedback across the 3 probability levels. And this is what you find. So in the partial feedback condition is quite flat, while only in the complete feedback condition, it is monotonic with the probability, which we believe is consistent with some form of curiosity-driven thing here and regret-driven in this case. So to wrap up, before diving into more complex analysis, what we have found so far is that if we look at the instruction, no instruction, there is a clear first trial effect that rules out the fact that at least learning is the sole determinant of the effect of feedback, okay? So when subject knows since the beginning that things is gonna be different, they are gonna behave in a different way, they change their attitude toward risk. We also found, and now actually I'm including 2 more experiments that for the sake of time I'm not discussing, we found a very interesting ripple interaction or double interaction, if you look just at the contrast, that suggests that this effect of feedbacks, it happens to be in the same direction, but could be driven by psychologically very different processes, okay? Now, of course, the fact that we find a first trial effect does not rule out that there is any other learning effect at the more microscopic atomic level of trial by trial adjustments. So upon first round of revision, what we did is to look at how the risk choice rate change as a function of the outcome immediately presented in the past, okay? So imagine you are in a situation with feedback between these 2 options, you pick the risky option, then the world can go in 2 possible states. That is, either you got a reward, in that case you got lucky, because the probability of reward was 10%, or you weren't lucky and the probability was 0, okay? I mean, and you got 0. So what we're gonna plot here is the probability of repeating the risky choice as a function of these 2 possible outcomes, okay? Now, the thing is that essentially any learning model at least understood as reinforcement learning, Bayesian update, etc., will predict that the probability of repeating a risky choice will increase after getting a positive outcome following the risky choice. Okay, so we look at this in our two experiments as a function of the probability, but also in average, and these were actually the results. I'm just separating by partial and complete feedback because they are very radically different things. So actually the result is completely the opposite. So when the probability of repeating a risky option after a reward is lower compared to the opposite case, with a very clear interaction with the probability level, which in fact is completely consistent with a form of gambler fallacy. Essentially, people do not understand well statistical processes. They thought in this case, for example, that they got lucky and they think I will never win again. On the other side, when the probability is high, they choose it all the time. Okay. And yeah, so that was also an important result for us that show us that even at this microscopic level, we don't find signs of level. Okay. But I'm going to skip this, but just to show that in one laboratory, we also used the losses. We could not test all the possibilities because we didn't have sure better. But anyway, in this laboratory setting with losses, we find, we replicate the results concerning the directionality of the effect and also the first trial effect. It's a seventh replication. Okay, but maybe the most exciting part, the things I will discuss here is I came back to the literature and I mean, actually everything has been done by Antonis, the amazing student behind this study. So we decided that it was interesting to at least identify one very important study in the past. This study by Ido, Ori, Doron, all these amazing people. For me, it was already very instrumental to get acquainted with this literature. We learned a lot and super interesting. And the good thing is that they also have very strong open science practices, and you can easily find this data, you can easily find the model. And I mean, I'm putting the citation because it's for right reason, a very influential and bounded to become even more influential stuff. So we wanted to see whether in this data we could replicate some of the results, and admittedly, this study was much more exhaustive in the terms of the type of decision problem that were used, which also featured ambiguity, Ellsberg paradox, extreme probability, but with mixed gambles, etc. So what I'm going to show you is replication across 400 subjects, but only on a subset of decision problems that is actually the one that are similar to our decision problem. So a contrast between a risk in the safe option with unequal expected value so that we can assess optimality. We avoided dominated problem. We avoided Alle paradox, extreme uncertainty effect, etc. Okay, right. So first of all, can we replicate the average results in terms of the directionality of the effect? The answer is yes. So we found that taking into account only this decision problem, even retrospectively, we find the same effect. Is a bit smaller, but since there is a lot of subjects, it's also very robust. Indeed, also in this data set, feedback increased the propensity to pick the risky option. We also replicate the fact that there is non-beneficial effects on maximization, as we have found in average. Now, second question, can we replicate the first trial effect? Well, not quite, because there was no, I mean, we cannot replicate it exactly, the analysis, because in this study there was not a manipulation that corresponded to instruction, but when you read the paper like a Bible and you discover all the details, you know that actually the subject passed through different versions of the task, okay? One version of the task, it's called by decision problem. So you have problem 1, problem 2, problem 3 in 5 trials without feedback and then with feedback, okay? And other half of the subjects, they passed the task in a way that is called by feedback. So they did all the without feedback trial at the beginning and all the feedback trial at the end, okay? So for us, you can tell that in a way, the first version assuming that the subjects, as I believe, they are not counting the trial, because why would they, corresponds a little bit like the no instruction situation. So the subject here will at some point discover that feedback will be delivered. On the other side, in the by feedback situation, it corresponds a little bit to the instruction, because after the first block of no feedback, you know that you will be for 100 decision problem in a without feedback situation. And then after the first couple of feedback blocks, you will be for 100 decision problem in the feedback situation. Well, if you are on board with me, and then you look at the result in this way, interestingly, when you look at the by decision problem subject, in the first trial with feedback, there is no difference. And as soon participants discover that feedback that is delivered at trial 6, boom, it jumps to the final level of preferences. And here, interestingly, since we are more in an instruction-like situation, there is no feedback attitude. And then we immediately find that there is a very flat feedback attitude that is expressed in all the rest of the feedback trials. Okay. Finally, so we can say we found a pseudo first trial effect. Are these results consistent with regret? So yes, actually more than our data to some extent. Now, if you plot up the effect of feedback as a function of the probability level, here is not like only one. So we make big bucket but with different levels. You find exactly this. So you can see a very nice monotonicity of the effect of feedback as a function of the probability. As a reminder, these were our results in the feedback situation. So answer is yes. Finally, do we also find sign of the gambler fallacy in this data set? Yes, pretty much same size as us. So people tend to move out from the risky option after being rewarded on the risky option. Okay. And this is something now I'm going to present is not even the preprint, is very new. It's going to be included upon revision. What we wanted to do, and actually Arab saw some of the results in Lille, but not this one. This paper presents a model. This is called BEAST, for best estimate and sampling tools. I think the A is for end, but anyway, the BEAST model, which it was the winner of the choice prediction competition to start with, which is already an achievement, and is becoming, I mean, like for good reason, a reference model in the field of judgment and decision making. For example, this be used by Peterson et al. As a benchmark in their approach in which they want to compare to neural network. Tobias used it like as a generator of synthetic human data because it's supposed to be a model of human behavior in this task, etc. So again, the results are new, but since the code were available, we're able to replicate and simulate the BEAST model in our data and see how it fares in terms of simulation. So first of all, how it works. I mean, I'm really, in Italy, you say, I'm working on eggs here because I will not explain to Ido or et cetera, this model. But this model is a learning model, right? So it has a rational part, the unbiased tool. It has also biased tool. But at the end of the day, as soon as the empirical distribution become available, it's pretty clear that the model is going to replace the prior distribution from the description from empirical distribution. Okay, it has several parameters. One parameter phi could not be fitted in our data set because we don't have ambiguity. Actually, we refitted the model. I think it is against the philosophy of choice prediction competition because the idea would be that you don't need to overfit in your known data set. But nonetheless, we wanted to give the model the highest possible chance to be the best possible fitted model to our data. And so we fitted and then simulated against different variables. So first of all, is the BEAST model capable of fitting or explaining, capturing the first trial effect? No, it is not. As I said, it is a learning model, right? So it predicts that the curves diverge, but it also predicts that they should be the same before experiencing any feedback. Does the BEAST model capture the interaction with probability? Yes, it does so in the complete feedback, because one of the biased tools is actually regret. So, and that's also the importance, right? The model are as good as the data. The choice prediction competition data is only complete feedback. And indeed, regret is an important thing in complete feedback. So the BEAST model captured that, but it fails to capture the curiosity effect. So in the partial feedback, the model will still predict a monotonicity or an amplitude of monotonicity that is only the data. And finally, the question is whether or not the model capture the gambler fallacy. And the answer is not no, because it is still a learning model. So it's leveraging on the empirical distribution. So we don't find in our simulation and fitting that the model is capable of fitting. Now, I hope everybody understands that I'm mentioning this fact because the model is very important and this paper is very influential, but I have any beef against the model per se and the people behind. Right, so I'm going to wrap up. Forgetting about the interpretation in our data, what is the effect of feedback in risk? It increases risk. What is the effect on optimality? No effect on optimality. So you cannot dream that you add feedback to improve optimality. It doesn't work in our experiments and actually also in other experiments. It seems to be not a learning effect, but attitudinal effect, which is demonstrated by the first trial effect. Then maybe there are other learning processes on the top, etc. But it's at least not the major driver is not this. Second, we don't find sign of learning, at least naively understood, as either belief update or reinforcement learning, even when we look at the trial by trial dynamics. As a matter of fact, we find quite the opposite, a sort of fallacy. We also have the complexity, and this may be also the fate of the paper is not so easy because it's a very hard to digest paper, that the effect of feedback is paradoxically the same in average, but driven by very different psychological processes in the partial, in the full complete feedback scenario. We believe curiosity and regret are very good common language proxies. We could replicate all the results that we could replicate in previous data sets with the caveat that we only focused on a subset of comparable decision problems. And we found that some of the results cannot be captured by the BEAST model. And I want to conclude for the debate is that it seems that, first of all, that there is not experience feedback that changed the decision, but the fact that feedback changed the experience of the decision that is driving the effect. And then I think the interesting things to throw here is the critique of the data-driven approach to judgment and decision making. And the quote they're making, if you can't predict, you cannot claim to have understood something, came from Ido when I invited him to speak in Paris in 2018. And when he was presenting his results, it's really stuck with me. But I think what we also show that you can still predict without having understood, because you can still find metrics that are against the model, so that from the point of view of a psychologist interested in understanding the psychological mechanism, prediction may not be enough. Okay, and I hope I will not die after this presentation. And with that, I really wanted to thank the co-authors and the collaborators, Fabian, Elise, Maël, and especially Anthony's, which has done all the work. And thank you very much for your attention.
Okay, thanks very much, Stefano. Yeah, okay, so let's open the floor for questions. I have some, but let me give other people a chance.
Can I just
Yes.
Yes, Stefano, and apologies, I'm a bit sick, so apologies for my voice and everything. When you say the gambler's policy, you mean negative recency, right?
Yes. It's we're gonna write it like this. Yes. So maybe it's a shortcut, but actually, Antonius, the student, we have this. You can say it's a negative recency effect. Yeah.
I'm saying because the 50-50 is the gambler's policy, but when you go to the other probabilities, like you shown, right? So it will not be accurate. Okay.
Yes, I think in the paper we are unpacking this a little bit more, including mention of the explicit mention of the recency effect. But thanks as a reminder, we're gonna come back on this.
There's actually a way to check if it's gambler's fallacy, because the gambler's fallacy implies, sorry for interrupting, the gambler's fallacy implies that the longer the sequence of outcomes that you see, the higher the probability that you'll avoid it, right? You can actually plot the function as the response rate as a function of the length of the sequence. So if you won 3 times, you're much less likely to repeat after 3 times than after just one time. And if I'm allowed to make a bet here, there's absolutely no way this is going to happen for a long sequence. As by the way, we show in a different data set in a different paper. So you can check if it's a gambler's fallacy.
We will, Ori, and I'm unlucky I don't have to take notes because Anthony is connected, so he's hearing this remark, and we're going to check this. It's a good point. I think Jim has a question.
Jim.
Oh, yes. Yeah. Well, thank you. That was fascinating talk. I think it raises some really interesting questions. Since you've been on a search for other results that might corroborate, I mean, I think you focused on a very important and interesting phenomenon that I think is as yet unexplained, which is this first trial effect. And I guess, you've presented some, hypotheses about why that might be. I just wanted to let you know that I have some data actually that shows that same first trial effect. It stems from the dissertation of a student of mine back in 2001, Yujia Chen. And he did, and Ido knows that Ido was in fact on the committee. So we have some data. We didn't really analyze it for the first trial effect. I think, you are very perceptive to have noticed that and noticed that it's really important. So, but the data actually is there, sort of scattered between studies, because we had a couple of conditions. One was we offered people the chance to make prospective multiple decisions. Like if you could play this 10 times, what would you do? If you could, and contrasted that with a feedback condition. And, the differences there, I think, are indicative of the first trial effect. So anyway, I'll check and see if I can find that data, but I can put a couple of references.
I mean, Jim, first of all, it allows me to say my ignorance in the field is boundless. So, please send me any reference that I might have missed, because that's, not at all my original field. And there is still room to incorporate them upon revision. So I would be actually the more things exist, the best is for us to understand what's going on. So I can put
a few in the chat in case anybody else is interested. One thing about the attitudinal, the idea that people might learn attitudes rather than learn to maximize, that was raised way back when by Jim March in a paper in, I think, 1986. I can't remember the exact date. So, I mean, that idea has been around for a while. I'll send you that reference too. Actually, I'll put them in the chat.
Thank you very much.
Sure. Okay.
Yeah. It's me, right, Ori? I can talk.
Yeah. Go ahead.
Yeah. So thanks. So it's very interesting, and I agree with you that BEAST should be improved. One direction that I will start thinking of, I'm not sure if this is, I thought about it early on when I worked with Jim, talking with Jim about it, that one way to explain this is that people always make decisions from experience, but their experience, not only previous trial, but also experience that happened before the beginning of the experiments. And BEAST try to approximate it, but approximate it in a very crude way, or very specific for decision under risk. In our next competition, we are looking at the impact of descriptions. It could be any verbal description. And now you have to think about more careful past experience. But one generalization of past experience that could explain your first trial effect is that in many natural settings, if you don't get feedback and you cannot check if someone is tricking you or not, you should be very, if someone say, let's have some deal, and maybe you earn money, maybe you lose, and you don't get feedback, say, no, I don't want to do that. But if you say, take risk with me, let's take, I give you kind of option, it's a little bit risky, but you will be able to see the feedback after each trial. Now you say, well, let's try. So I think this first trial effect could be effect of experience, but an experience that subject bring with them to the lab. And this is one of the things we hope to do in our next, in our refinement of BEAST, because I think this is a really important effect that you come to the lab with some prior belief. And definitely giving your money to someone and never getting feedback, this is not a good idea.
No, yeah, I agree. I mean, Ido raises a very good point. The fact that even should be a meta level in which these attitudes are learned, right? So why should be the case? And I also agree with you that in many times it is pretty intuitive to start to framing what is the ecologically relevant situation in terms of social interactions. And if I understand correctly, what you're suggesting is that okay, you are proposing me something risky, but now we're gonna see really what is going on. So I'm more propense to take risk together because gonna be disproved or not. Yeah, I think it is possible, but I think that I agree that we are not denying that some meta learning process can occur in the creation of this attitude. Should come from somewhere.
Thanks.
I don't know if Kidder, if you have another question because your hand is still raised or it was before.
Yeah, I wanted to ask if the first trial effect, could it be explained by the curiosity? So it shouldn't be something different from it, right? So in a sense, you know that there is a risky option, so and you know you're going to get some feedback.
So I think so for me the idea is that first of all I accept that this can come from other experience before the lab, but maybe we should call it like a mindset. And you have two mindsets, and if there is feedback, you will go with the mindset that is I like to take risk in the partial feedback because I'm curious and I want to resolve the uncertainty. Or there is the other mindset, there is anyway, I'm not gonna know, so you know what, I will be play safe, etc., because I don't have this extra thrill of discovering what's going on. Okay, so
so
then for me the instruction for me now, just to clarify, just I think it's important that I don't think that is the instruction inducing. It's just the instruction revealing the fact that these two mindsets exist. And even in the case of the instruction, it's only also the mindset shift effect. It's just that without instruction, you have to experience one feedback to know that you have to activate your mindset, right? So I think it's important to clarify here. I don't think there is a magical effect of instruction. It's just instruction is my instrumental tools to activate, to control the rise of the mindset ex ante before the first choice. In absence of instruction, the subject is dubious at the beginning, and then discover that the subject has to activate the new mindset after the first feedback. Because the feedback is the only sign that gives the information, you know what, this block is going to be with feedback or without.
So I totally agree with you. So actually, I think that the mindsets that you're talking about, maybe they be some kind of more general mindset, like exploration, exploitation kind of mindset, in the sense.
Yes.
So when you know you're going to get feedback,
so.
You move to kind of more exploratory mode.
Then we fully agree with the caveat that this should be the case in the partial feedback, but less so in the complete feedback. As a matter of fact, the effect is superficially the same, but structurally different, because in one case it is monotonic with probability and all the speculation about a role for regret.
Yeah. Thank you so much, Stefano.
Thank you.
Can I?
Yeah, go ahead. Yeah.
Hi. I also agree it was fascinating. I enjoyed the talk very much. Thank you for that. Just to recap on this exploration thing, I think that the data also noticed that the risk taking in the graphs you showed, maybe I missed something, but it seemed to be below 0.5, which seems to be in line with the exploration idea. Also, I'm not sure it's risk-taking per se that increases, but it could be the thing about changing the mindset towards exploration. And then when you have regret, of course, you have this effect of regret. So.
Yeah. So I think that's maybe, Eyal, you will tell me if I understand correctly your point, and I think I agree with you. I don't think it is a modification of the utility of the utility function, right? It's something else, maybe a bonus model, something would be more appropriate to capture this effect. But I agree that probably the target is not the risk per se, is the fact that now we are in a new experience, right? The task is creating a new experience in which I can complement the utility of the risk option with something coming from discovering the truth about the state of the world, which I wouldn't if I pick the safe option.
Yeah, that makes sense.